Hello everyone, and we are provided with 4x, 3x, 2x, 1x master mix. We add it to the reaction, and the final volume of this reaction is 18 microliters. We add master mix to the final reaction. We also are provided with the concentrations of other components, but the main point here is the forward and reverse primers. So we need to find the number of primer molecules of a single type, so it's either forward or reverse. And we take forward, we don't need reverse, we don't need dNTPs, and the salt and the tag polymerase, so 3 micromolar concentration. So now we know the conditions, and we can find, for example, for 2x master mix, we had the concentration of 3 micromolar for primer forward, and we also knew the working volume, which was 18 microliters, and now we can find the number of molecules, which is n. First we need to define what is 2x, and whenever you see 2x, 5x, 50x, 100x, it means that you have the concentration, stock concentration, which is 2 times, 5 times, 50 times, or 100 times higher than your working concentration. This x means multiplication, so you multiply it, and in formula it will look like C stock equals 2 times C work or working concentration, and depending on this coefficient you will put it here. So this is the place for coefficient. In our case, for 2x, we will have C stock equal 2 times CW. Okay, so from now we can put this equation into our formula. So our formula was C1V1 equals C2V2, or C stock, volume stock, equals concentration working, volume working. From this we know C stock, and we know the working volume, and we can find it. So we just put CS from this equation. So when we change the CS, it will look like 2CW times VS equals CW VW. Now we can get rid of working concentrations, and we're left with 2 stock volumes equal 1 working volume. And we know that from here stock volume will be equal to working volume divided by 2, or 18 divided by 2 microliters, 9 microliters. So now we know our stock volume, and it will be 9 microliters. We also know our stock concentration, which is 3 micromolar, and from here we need to know the number of molecules. We also know the Avogadro number, which is 6.022 times 10 to the power of 23 molecules per mole. And now we have the formula, which is N times number of Avogadro, and this guy will be equal to C times V. From here we know that 9 microliters times 3 micromolar times 6 times 10 to the power of 23 per mole, and we need to represent these microliters and micromolar concentration in liters and molar per liter to be able to get rid of these moles and liters. And it will look like 9 times 10 to the power of minus 6 liters times 3 times 10 to the power of minus 6 moles per liter times 6 times 10 to the power 23 per moles. And we get rid of liters and moles. And we are left with 9 times 3 times 6 times 10 to the power of 23 minus 6 molecules. And it will be 9 times 3 times 3 from 6, it's 81, 81 times 2, 162. And to represent it in a scientific way, so 23 minus 12 is 11, and we move the decimal point to here, and this will be 13. So we found that 162 times 10 to the power of 13 molecules will be in our 9 microliters 3 micromolar concentrated master mix. So the final answer is 1.62 times 10 to the power of 13. So the physical representation of these equations were these. You have your PCR tube, and you have your working volume, which is 18 microliters. So this is working volume. And your stock was a half, and your stock was 1/2 of this working volume. And you just add half of your master mix. And your other side will be 1/2 of working volume, and it will be your solvent. In this case, so this is the PCR, and it is our DNA sample. This was for 2x master mix, and let's look at the 3x. So for 3x it will be the same logics. You have your PCR tube, you have your working volume, you will have 1/3 of this volume of master mix, and 2/3 will be your solvent DNA. So if we have 4x master mix, the same logic applies. You need to divide this working volume by 4, and one part of it will be your 4x master mix, and 3 parts will be your DNA. So the last condition was 1x master mix, and to find it you take the whole volume of your master mix. So where is the DNA? The DNA will be a dried DNA, and technically it means that you dissolve your DNA in master mix. I don't think it will happen in your real life, but you just need to know what is 1x. Now we're going to find the number of molecules for 4x master mix, and it will be your stock concentrations times working volume divided by 4 because of this 4x times number of Avogadro, and it all will be equal to 3 times 18 divided by 4 times 6 times 10 to the power of 23 minus 12. And we will be left with 3 times 4.5 times 3 times 2. So these 3 and these guys will make 9 times 9 times 10 to the power of 11, and it will be 81 times 10 to the power of 11, and we place decimal point of here 8.1 times 10 to the power of 12. For 3x it will be 3 times 18 divided by 3 times 6 times 10 to the power of 11, and this will be equal to 36 times 3, 108 times 10 to the power of 11, and this is 1.08 times 10 to the power of 13. For 1x master mix it will be 3 times 18 times 6 times 10 to the power of 11, and in whole it will be 324 times 10 to the power of 11, or 3.24 times 10 to the power of 13. So we found all numbers. - 3.24, 1.62, 1.08 and 8.1.